Okay, YouTube, this is our first video in which we're going to be performing matrix operations. And so when we refer to operations, let's go ahead and review what we mean by an operation. We say that operations, okay, are things like addition, subtraction, multiplication, and division. So what I can tell you is that in this video we're going to be focusing on addition and subtraction, but with matrix operations. Let's go ahead and make a list here. The ones that we are going to be exploring, the ones that are defined are addition, okay, addition, subtraction, also, scalar multiplication, so multiplication by a scalar or a real number, but also multiplication. So you'll notice that division is not going to be on this list, but these are all the operations we're going to cover, of course, starting here with addition and subtraction. So you can see that this table here, it's noted that it shows that matrices of the same order can be added or subtracted by simply adding or subtracting corresponding elements. And so when it comes to adding matrices, it's a pretty straightforward thing I have to tell you, or subtracting them, because we would just say that if A is some matrix full of all these little aij's, and B is some matrix full of all these little B's in the ith row, jth column, and they're both of m by n order, so they have to have the same order, then we could say A plus B really is this new matrix here, and this is kind of, I suppose, hard to read. They say it's this new matrix where we get Aij plus Bij. So really the implications of this are that we get a new matrix where all we do is add together corresponding entries. Whatever's in the ith row and jth column of the first matrix, we'll add that to the ith row and jth column entry in the second matrix. So we say that matrices of the same order are added by adding the elements in corresponding positions. And as an example, in this table, they give this here. We see this 2 by 2 matrix here. So a 2 by 2, not a bad idea to write this down here. So we say a 2 by 2 plus a 2 by 2. So it's definitely defined. And what I want you to notice is that we would say 1 plus a negative 1 here. That's exactly what they're doing here. We'd say then on our resultant matrix here, then our first row, first column entry would be 0 because 1 plus a negative 1 is 0. And likewise, negative 2 plus this positive 6, because they're both in the second row, first column. Add those together, we get second row, first column entry in our sum matrix, which is 4. So 3 plus 0 is 3, and 5 plus 4 is 9. So one thing I do want to mention about subtraction is that often what we're going to see is that subtraction can also be written as A plus the opposite of B. And I'm going to make a little note here. We haven't really discussed scalar multiplication yet, but I can tell you the opposite of B would just be the matrix full of all of the same elements of B, but we would make them their opposite. So we say that matrices of the same order are subtracted by subtracting the elements in corresponding positions. So in other words, we could see that 1 minus a negative 1 here, that's the same thing as 1 plus a positive 1. We would get a 2 here. How about a negative 2? We would subtract off the positive 6 over here. Negative 2 minus 6, okay, we get a negative 8. 3 minus a 0, 3 minus 0, we get a 3. And then 5 minus this 4 here, 5 minus 4, we get a 1. So here would be our difference. So we have a sum and a difference. And so what I would like to do is look at what would happen if we tried to do this with matrices that don't have the same order. And I could put it to you really simply. We would just say that the sum or difference of two matrices of different orders is undefined. So for example, if we're talking about A and B here, we would say, what would A plus B be? And so we would say that because I don't have corresponding entries, or at least they don't have the same order, then we can't say that there's truly corresponding entries in a one-to-one fashion. And so we cannot add these, and we would just say A plus B is undefined. And we could just leave it at that. It's kind of nice. I like when that happens, but you gotta recognize it, because I get plenty of people that often maybe having a bad day at first, and they say, well, can I just add these together? The first 4 here and these first 4, and then we'll just leave these the same. You can't do that. It's undefined. So let's take a look at just doing a couple on our own here. I'm going to leave a couple for you, but take a look at these first two. If we said performing the indicated matrix operations, let's go find these sums and differences here, the sum and difference. We notice that we have a 2-row, 3-column matrix plus a 2-row, 3-column matrix. So what this means, at least for letter A here, is that our sum also has to have 2 rows and 3 columns. So we're going to get 3 separate entries in the first row and 3 separate entries in the second row. But looking at these, we would just add them corresponding entries. So 0 plus a negative 2 is a negative 2. 5 plus a 3 is an 8. 3 plus a 5 is an 8. Now our second row here, we say a negative 2 and a positive 7. We get a 5. A positive 6 and a negative 9 is a negative 3. And then last but not least, our negative 8 here plus our positive 6 here would be a negative 2. And so this would be our sum. So now looking at our difference, difference here, we notice that we're subtracting all of these entries in here. So we have to be careful how we do this and how we think about this. But we have a 2 by 2 minus a 2 by 2. So let's go ahead and fill out a blank 2 by 2 matrix that will be our difference matrix. So looking at this, we get excuse me, negative 6 minus a negative 5, which is really negative 6 plus a positive 5, so we get a negative 1. Okay. How about a 7 minus a 6? That's easier. That's 1. 2 minus a 0, that's even easier. That's 2. And then we get a negative 3, taking away 4 negatives, really negative 3 plus a positive 4. So this becomes out to be a positive 1. So what I'd like for you to try is just find this sum and difference on your own and see how comfortable you feel with that. Cheers.